So we talk about the general 4 components of refrigeration system. And refrigeration encompasses air conditioning, cooling air for personal comfort. And so we have the compressor, we have the condenser, we have some expansion or metering valve, and then we have the evaporator. And so the refrigerant flows into the compressor, then into the condenser, then to the metering valve, then to the evaporator. Now, those 4 components are in your home, and let's talk about finding those 4 components. So this is from Goodman Manufacturing. Anybody from the city of Houston? Hometown of Houston? That's the headquarters of Goodman. They probably have about 15% of the residential air conditioning market in the United States. They were recently bought out a few years ago, but I don't know if their headquarters is still in Houston or not. Okay, anyway, you have this big box on the outside of your house, and then you have a big box that's either in the attic or in a closet. Okay, let's try and identify, where is my compressor? Where is my condenser? Where is my expansion valve? Where is my evaporator? And they're either going to be in the box that's on the outside or the box that's on the inside of the house. So let's talk about the compressor, the noisy thing, the thing that sucks all the power, the thing that takes not 120 but 240 volts. That's the power to run the compressor in a residential air conditioning system. Where would it be? Outside. So it's out here. And then where is the condenser? Where you're going to reject the heat. You're rejecting the heat out of the system. You're going to reject the heat to the air in the middle of summer. And this fan right here is going to take and suck air across the condenser coil and blow it out the top. And when the thing is running, if you put your hand over it, you can feel the warm air coming out the top. That's why you don't grow shrubs and let it encroach in on it or put it packed in the wall. You need to give it space so it can draw in air and work efficiently. So these are on the outside. Outside. Where's the expansion valve? Inside or outside? Inside. Because as soon as it expands, what is the temperature of that refrigerant when you drop that pressure? It is cold and it's ready to evaporate. And your evaporator is in here. So this is where the coil is. And the air in the home, just like there's a fan in the condensing unit or condenser on the outside, inside they have a fan, and it takes the indoor air, blows it across the evaporator coil. That drops the temperature, and then it puts it out into typically a ductwork, which then will distribute it. Sometimes the ductwork's in the attic and drops it into different parts of the home in the ceiling. Here's a blow up, a cutaway. So here is where the compressor's at. This one looks like it's a hermetically sealed compressor. Usually if they're a little bit slender and taller, there'll be a scroll compressor. This one looks like an old traditional reciprocating compressor, piston sliding back and forth in a cylinder. Then it goes to the coils. The coils would be wrapped around, they try to wrap it around 3/4, if not more, of that box. But usually you have some service panel and some where the lines come in and out and the power comes in and out. So it can't be 360 all the way around. Different designs on those coils. I know the Train likes to have these spiny type of cooling condenser coils. Most manufacturers have it like an automobile radiator. They have fins, louvered fins, and so here's your fan to draw the air, is like we said, across the coil and then reject it out. We have some lines that move the coolant, the refrigerant, back and forth. One line will take it inside, and the other line to return it. And so two lines, usually they're copper. One will be insulated, one will be uninsulated. And then up here they have an evaporator. They have it usually sloped such that when you draw hot, humid air across that cool evaporator coil, you'll get some condensation on the outside of that coil, and that will then drain, that liquid water will drain down into a little catch pan on the sides, and then they'll drain that condensate out of the house. They may just dump it outside, they may dump it down a sink, but they need to get it where it's safely disposed. And so that's why it's typically shaped like this, or maybe sloped in another way to use gravity. And now we have a fan, a blower motor. It draws air in. Here's an air return air. It could be ducted. In a lot of homes, it's not ducted. It's just through the hallways to get to the return air. Put it through a filter. Make sure you keep your filters clean. Otherwise, get your money in the bank ready to pay for when your air conditioner system goes down because you didn't keep the filter clean by replacing it often, because that's what will happen. What will happen is all that lint, dog hair, cat hair, your hair, junk, dust, instead of collecting on the filter and then being thrown away every month or 2 months whenever you change your filter, it'll collect right up here where you can't really get to it easily, and the serviceman can't get to it easy. And they'll have to cut that A coil out, and they'll have to take it out and clean it and then put it back in, and that'll cost you, probably now about $1,000. And that'll be a cheap, instead of a $6 filter every month or a $10 filter. Or you can get a really good filter, maybe run for 3 months, 6 months even, on a very deep pleated filter. Anyway, change your air filters. Where's the expansion valve? Really hard to see in here, but as soon as you go through that pressure drop, it's going to be ready to evaporate. So right here is an expansion valve. This line coming in carries some high pressure fluid, the refrigerant. It drops it. For this system, there's 4 little outs. They go to different sections of the evaporator coil that's in this upside down V, or they really call it the A coil. I know they could call it the V coil, but they call it the A coil. It looks more like an A than a V. I guess instead of having an upside down V, think about putting a little, it's called the A coil. That's the slang. Okay. And then you can see it's collected in 4 places, and then it's collected up in a manifold and then returned. So that's the route that it takes. This little device often has a sensor bulb that comes over and is strapped to the suction line, the return line, such that it can sense what is the temperature of the fluid going out. If it's too warm, let more refrigerant into the evaporator. If it's too cold, cut it off. Don't let so much in. So there's a feedback. It's a control system. It's like a thermostat in your car, right? Some mechanism by which it regulates the flow. So that's a thermostatic expansion valve. It's just another acronym. And here they have it in 1, 2, 3, 4, 5, 6, going into 6 different places, collected in 6. So this illustration shows 4 pathways. This one shows 6 pathways through the evaporator. Okay. Why do they call this the liquid line? Because the state of the fluid in that line being supplied up to the expansion valve and then immediately after it the evaporator is in a liquid state. What is the pressure in that liquid line? High or low? High pressure. It's high pressure. Okay. And then what you look at this, I like to point out some things that really don't make sense when you're first introduced to it. Look, if one has the liquid line, why don't you call this the vapor line? See the parallel? One liquid line, one vapor. You're describing what's in it. Oh, it's vapor in that line, but that's not it. They call it the suction line. Why do they call it the suction line? Because it's going down to the compressor. When the compressor kicks on, what does the compressor do? It sucks on that line to draw the refrigerant out of it. And that's what the compressor is doing. Okay? So, okay, fine. If you like to call it the suction line, then let's not call this the liquid line. We'll call this the push line. You know, you're going to suck on one line, push on the other. Don't try and change the world. Just get used to the terminology that's out there, okay? One's the liquid line, one's the suction line. Got it? All right. Here is a close-up of that thermostatic expansion valve with that bulb, and the service technician can move it, you know, and place it, and then strap it on to the outlet of the suction line right immediately after the evaporator. And it's a little, I mean, these are fairly cheap, but they're well engineered. Little needle valve, and this diaphragm up here, sensitive to the temperature and pressure, and then it moves it up and down. You have the same metering in the automotive air conditioning system. All right, so where is our condenser again? Where's our condenser? On the outside. Where's our evaporator? C, on the inside. Where's our expansion valve? The hardest one. No, it's right next to the evaporator, right next to that A coil. It's on the inside. C. Where's our compressor? Yeah, on our outside. Okay. Well, this A is really showing our liquid line and our suction line, those lines that carry fluid back and forth. What's E showing? Thermostat. D is showing some ductwork and maybe some grills that supplies it into our home. And C is the big box, either in the attic as shown here or in a closet. All right. Now, there's two lines. I forgot the name of them. What are the two names of our lines that move the refrigerant back and forth between the inside and outside of the home? Suction line and liquid line. Okay. Which line is short? Meaning it's not very long. Is it between the compressor and the condenser, between the compressor and evaporator, between the condenser and expansion valve, or expansion valve and compressor? What we're going to do is you'll raise your hand, I'll call on you, you'll answer it, and then you're done for the day in answering questions, if you get it right. All right. So where is our compressor? And our condenser coil is right there. That will be very short. That'll be very, very short. You're right. You're done for today. Thank you. Which line of these four is long? Yes, sir. A again, between the compressor and the expansion valve. So what is the name of that long line that goes from the compressor? Actually, do we go from the compressor, or do we have a device in between the compressor and then the expansion valve? Yeah, that's called the condenser. So I'm going to let you change your answer because technically
the line goes through all of it, right? So it's still the longest line.
We don't want to be technical. We want to be accurate. We want to be right. Yeah, because everything's in a loop, right? But we're talking about, this is the compressor. Then we have the expansion valve. And so it doesn't go directly from the compressor to the expansion valve. It goes compressor to the condenser, condenser to the expansion valve to the evaporator, evaporator to the compressor. B, evaporator and the compressor. So this line is very long. And what's the name of this long line? What is the name of that? Suction or liquid line? Okay, this is our suction line. So you're out, you're out, you're out. All right. For the short line between the compressor and the condenser, there is no name for it. So this line right here between the compressor and the condenser is very short and no name. Likewise, between the expansion valve and the evaporator is short and no name. The long one going all the way from the outside, inside to the outside of the house, that's long, that's the suction. And this one is long, and it goes from the outside to the inside. What's the name of that long line? Liquid line, right? Okay. The liquid line goes from, and since you already answered it, I'll let you answer this one. From the condenser to the expansion valve, and you're done for the morning. The suction line goes from, somebody new. Yes, sir. So it goes from the evaporator to the compressor, B, right? Done. All right, new. We have a lot of questions. Which line transports liquid? The small diameter or large diameter line? Let me ask you a question. We have two lines. One goes into the house. That's the liquid line. One goes out of the house. That's the suction line. When you look at these two lines, they will not have the same diameter. One will be small diameter. One will be large diameter. One will have a, you know what I'm saying? So the line that transports the liquid, okay, is it the one that has a small diameter or the one that has a large diameter? You have to get my attention, raise your hand. You have to be new. No, you already did it, didn't you? Oh, this is your first chance.
This is my wrong chance.
No.
The small diameter.
Small diameter, small. And that's really a hard concept for a lot of people because look at the mass flow rate of the liquid going in the liquid line compared to the mass flow rate of the vapor in the suction line. And in this, the mass flow rates are the same, so mass flow rate liquid equal to the mass flow rate vapor. That's true. Now, is the mass flow rate equal to, let's say, the volumetric flow rate, AV, times some density of the fluid? Let's use density instead of the reciprocal, which is the specific volume, 1 over that. So you have the volumetric flow rate of the liquid times the density of the liquid equal to the volumetric flow rate of the vapor times the density of the vapor. Now, can you tell me which one has a high density? Does my liquid refrigerant have a high density, or does my vapor, the refrigerant in the vapor form? Oh, you already answered. You got to be quiet. Yes, sir. The liquid has a high density. This is a very high number, but the product of a large number times something is equal to the same. So this one's small. So what we have is we have to have this one can be small since this is large compared to this one is small, this is large. So we need a smaller area. The area for the liquid line is small compared to the area, cross-sectional area for the suction line, which runs the vapor. And so our areas, I didn't leave enough room here, but that's the diameter liquid line, because isn't the area pi d squared over 4? I know it's not proportional, it's d squared, but so you have a small diameter for the liquid line and you have a larger diameter line for the vapor or suction line. Okay, which line transports vapor? No, we're going to, yes, sir. It's a large diameter. See, what they're doing is they're paying attention and they're getting answers correct. And I'm engaging everybody in my class. How do you like that? All right. Which line now is cold to the touch? We're going to take our fingers, and you can touch these lines. You can go to the house. Be careful around your house. You could have the electric line could be improperly covered up and maybe have a bare wire there, but most of the time it's pretty safe. And you go back there with your finger and say, hey, there's a small diameter line. Let me touch it with my finger. See if it's hot or cold. That's called the liquid line, the small diameter line. That's the line taking refrigerant from the outside of the house into the house. Then I could put my finger on the large diameter line. Hey, that's the suction line. I can sense if it's hot or cold. That line's taking refrigerant from the inside to the outside of the house. It's getting trickier. Those that answered questions earlier kind of relieved. They got the easy questions. All right, so which line is cold? Yes, sir. That's a 50-50 guess.
Yeah, no, considering it just came in.
You just came in. Well, then let somebody else shine. The large diameter is the cold line. The large diameter is carrying the vapor. The vapor that just left where? The vapor that just left the evaporator. It just left the evaporator. It just, if I was taking air from the inside of the house at 75 degrees F, dropping it once it goes across the evaporator to 55 degrees F, all right, now it's nice and cold, and I dump it into my house. All right, it's cold air. Well, what is the temperature of the refrigerant that is inside the evaporator? Even lower than 55. Yeah. And now that's our suction line, our large diameter, that's going back to the compressor because the compressor's sucking and drawing it back away from the evaporator. That's the cold line. The large diameter suction line is the cold line. Which line is hot? A, the small diameter. And if that small diameter coming right after the condenser is ready to take the fluid, refrigerant, into the house. If you touch it, watch out. It could be really warm. Why? Because let's say you want your air conditioning system to still work when it's a brutal day. Let's say it's 110 degrees F air temperature. It's going to draw it across and blow it up. Okay, so what temperature do you think the refrigerant is in the condenser? You think it's going to be greater than 110 or less than 110? It has to be greater because it's dumping heat to the air that's at 110. The air that comes out may be 115 or maybe 120. I don't care what the air is that blows out the top. But the refrigerant inside probably is around 130 degrees F. It could be toasty. That's what's in the liquid line, ready to go back up inside your house. So, yeah, you can sense it. It'll be warm. All right, which line brings refrigerant into the house? Again, we're playing the game. You get to answer one question correctly, and then you're done for the morning. A, the small diameter line brings the liquid refrigerant into the house. Which line typically is insulated? There's a need to insulate one of them, and it's a very good reason to insulate the one. We have the liquid line. It's going into the house. It's hot. It's small diameter. If I insulated it, it would remain nice and toasty, warm, hot, right until it got to the expansion valve. Okay, maybe that helps, maybe not. Let's think about now the suction line. It came out of the evaporator. It's the larger line, and it's being pulled by the suction. The compressor is pulling it down. If I insulate it, what is cold or cool will stay cool down here. I'm thinking about the compressor. So would the expansion valve benefit by having hot liquid served to it, or would the compressor benefit from having cool vapor served to it? Because if I insulate, then I keep the vapor cool, or if I insulate, I keep the liquid hot. Let's say I don't insulate. Well, then the liquid's not going to be as toasty hot. It'll still probably be warm, but it won't be hot. Or think about the vapor. If I don't insulate, it won't be cool, it'll be warmer. You need to insulate the suction line. It's better for the compressor if you feed it saturated vapor, not superheated vapor. When you feed it superheated vapor, it's going to have to work harder. So that's why you insulate the suction line. There's another reason. If it's cool And that line has to pass through the attic or the walls or anything. And in the attic or the walls, you still have hot, moist air. What could you get on the outside of that cool copper suction line that would not be nice to condensate? Why would you get water on the outside of a cold line? It's just like having a cold beverage in your kitchen, on your kitchen table or something in the middle of summer. It starts to sweat. Where's that water coming from? The condensate from the air, because the cold surface is below the dew point temperature of the air in that room or the air in the attic. So we definitely don't want condensate forming little droplets and dripping somewhere in my attic where that suction line's going through. So good for performance from the perspective of the compressor, as well as I want to avoid condensate anywhere else in my wall or wherever that line runs. So which line is typically uninsulated? Yes, sir. Liquid line. It's actually better if there's a little heat rejection into the attic or wherever, and you get a slightly cooler liquid supplied to the expansion valve. That'll help a little bit. It'll improve just a little bit. Every now and then you'll see people talk about split systems. There's a bunch of novelties out there. Here they'll pipe the refrigerant into a smaller location right in here where they have a small air handler filter system, and then they'll just dump it right in that room. Here they'll have two compressor systems on the outside. You get split it up, not just one big compressor. You could have turn these two on but leave the third off, whatever, or run this one but not this one. Why do they do that? Efficiency, because somebody brags about the miles per gallon of their car or big truck. Well, look, if you don't drive your big truck, I can tell you how much fuel you're going to use. Nothing, right? You could save a lot of energy by not taking that long trip on vacation. You don't need to buy a lot of gas, right? You save a lot. Well, the same thing is true. We all know it. You turn the air conditioning system off to the house off, you don't have to pay for a lot of electricity, and so a lot of people do that with programmable thermostats. And this is becoming more and more common to be able to control not just the temperature of the whole house, but in zones of the house, and then let that one go off during the day and let that bedroom come on during the night when you want to sleep, and let that bedroom be very comfortably cold, and let the kitchen and living room and everything else get warm in the middle of the night. You can save more money that way. Okay. There's another one. Most of these are split systems, and the refrigerant flows in and out of the house. But every now and then you'll see somebody with a package system. What? Everything's in one package. The 4 components, the evaporator, the condenser, the compressor, the expansion valve, all that's in a package. So what goes in and out of the house? Just air. So you'll have air that's ducted out to the unit, and cold air will come back. They're kind of funny when you first see them. I remember seeing one, and it's like, what is this? This crazy thing. Because you need big ducts to move air. So it's kind of funny. You got big penetrations going in and out of the house versus those small line set, they call it, the suction and liquid line, just a small penetrations needed in and out of the house. These are not very common, but you'll see them every now and then. You also, for commercial, I know I'm focusing on residential, but if you go look at the top of especially malls and other places, they will have rooftop packaged units. Everything's in a package. Actually, a crane just puts it up and takes it down. When they need to replace them, they hire a crane. And they have a very nice system right here. It's so that it's plug and play. Pop, pop, pop. And so the air comes up below and cold air goes back down below. And so air just goes in everything. The 4 major components are in that rooftop package unit, and they can have a whole pile of them on top of a Walmart or on top of a Costco store, or big box stores like that, department stores. You can look on the inside. You could find those components on those rooftop package units. They're going to have the evaporator somewhere, the condenser somewhere, the expansion valve, the compressor. Also, when the person is servicing them, they just have to get up on the roof. They don't have to get into the occupied retail space or anything, or shut anything down. This is really rare, but I found a picture. This is somebody's house. This is the roof of their house. And for some odd reason, you can find crazy stuff. This is a rooftop package unit in a residential application. And I wouldn't want to be the roofer that has to come in and re-shingle. Because what are they going to do? They're going to probably have to get a crane to get that off, do a decent job of re-shingling the home, and then in the commercial world, they figured that out. They have this little box that's all packaged up. You can re-roof, have a roofer repair the roof without moving your rooftop units. But here, this is I don't know who did this. But anyway, you have a penetration for your electric, etc., and controls. And then this is just air supply and air return, I'm sure. Okay. And you'll find this is here a package unit, and I can just tell the way it's cut in. Big air ducts in and out right there. This guy must have found a sale on one, and the window unit that he put in didn't cut it, and so he's ducted his own. This is like super crazy stuff. But you could find it. So, what's a split system? You have the condenser system or package, which has the condenser coil and the compressor outside, and then the inside you have the evaporator with the expansion valve in the closet or in the attic. The suction and liquid line, the line set connects them up, and that's very, very common. Okay. Mini splits, you're seeing more of those where you're removing liquid and suction lines to a small box that's in each of the rooms or zones that's then can be turned on or off right there and not air condition the whole house. And then packaged units. They're more common for the commercial world, but every now and then you'll see them in the residential world. All right, I think we're done with that. Let's move on.